Number 26. Find the length of the graph of y is equal to the natural logarithm of sine of x over the interval from pi over 6 to pi over 4. So we know we're going to need the square root of 1 plus the derivative squared here. So let's start doing the necessary calculations. Y prime is equal to the derivative of this. So derivative of natural log of sine of x is 1 over sine x. We also have to use the chain rule and multiply by the derivative of sine x, cosine x. Cosine x divided by sine x is cotangent x. Okay, so now we are thinking about 1 plus y prime squared. So this is going to be square root of 1 plus cotangent squared x. This should feel like there is an identity floating around. Let's quickly derive it. Sine squared x plus cosine squared x is equal to 1. If we divide everything here by cosine squared x, what do we end up with? Hold on a second. We want sine squared downstairs. This is going to give us tangent squared. Let's not divide by cosine squared. Let's divide by sine squared x. So now cosine squared divided by sine squared will give us cotangent squared. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. 1 divided by sine squared x is going to be cosecant squared x. So this is going to be square root of cosecant squared x, which on the interval we're thinking about, cosecant x is positive. So this is just cosecant x in here. Okay, so now we are ready to have our integral. Arc length is the integral from a to b, in this case, pi over 6 to pi over 4. All of this, and then it's going to be the integral of the square root of 1 plus y prime squared. So we simplify that down to cosecant x dx. Okay, so at this point now, we just have to integrate cosecant x. I'm going to do this in two parts. First, I'm just going to write down the final answer, and I'll show how you obtain it. The antiderivative of cosecant of x is the natural logarithm of cosecant x minus cotangent x. Plug in pi over 6 and pi over 4. So if we want to simplify this, it's the natural log of the absolute value of cosecant of pi over 4 minus cotangent of pi over 4 minus natural log of cosecant of pi over 6 minus cotangent of pi over 6. Okay, let's simplify these things here. The cosecant of pi over 4, that is going to be, so 1 over sine of pi over 4. Sine of pi over 4 is 1 over root 2, so this is just root 2. Cotangent of pi over 4, well, tangent of pi over 4 is 1, so it's just natural log of root 2 minus 1, minus the natural log of cosecant of pi over 6 is 1 over sine of pi over 6. Sine of pi over 6 is 1/2, so that's 2. And cotangent of pi over 6 is going to be cosine of pi over 6 is root 3 over 2 minus 1/2. Those cancel out. So it's the natural log of 2 minus square root 3. Okay, so that's the main part of the problem. That's like the section 8.2 part of the problem. Let me just also show off how to find the antiderivative of cosecant of x. Okay, so what we can do is that we can multiply top and bottom by a substitution. Well, sorry, multiply top and bottom by the same thing, and this will allow us to have a bit of a substitution here. Okay, so all I'm doing is multiplying top and bottom by cosecant x minus cotangent of x. So now what happens if I do u is equal to cosecant x minus cotangent x? Taking the derivative here, so the derivative of cosecant of x is equal to minus cosecant x cotangent x. The derivative of negative cotangent x, so the derivative of cotangent x is negative cosecant squared of x, so plus cosecant squared x dx. And what do we realize here? Cosecant squared x minus cosecant x cotangent x, cosecant squared x minus cosecant x cotangent x. This is the u right here. So this integral is the integral of du over u. So that's natural log of the absolute value of u. And so that is natural log of cosecant x minus cotangent x. And that's exactly what we were using right here.